if in the ratio column, if you found two values are same, then the problem LPP is said to be degeneracy. The minimum value is given by elements of the first column of the unit matrix divided by the corresponding elements of the entering column. All the values in delta J are greater than or equal to 0. That means all the values are positive. Hence the optimality is reached. Hello dear students, welcome to this session of our class. I am Mr. Niranjan, Faculty, Department of Computer Science, Vidhyaashram, First Grade College, the Temple of Excellence. Now in this session I am going to discuss regarding the problems based on degeneracy. Now when we are going to apply the degeneracy concept, whenever a tie in the ratio column, so far we might have been studied the problems based on a simplex method, big game method and two-phase method. Now, in case of there is a tie in the ratio column, then we are going to use this degeneracy to solve the problem, to remove the degeneracy. Now, what is degeneracy in LPP? So, in any given problem or in any given iteration, in a linear programming problem, either by simplex method or by big M method, the leaving row is found by selecting that row which has the least positive value in the ratio column. So, the outgoing element, outgoing row, the leaving row is selected by selecting which has the least positive value in the ratio column. Having the least positive in the ratio column is nothing but the outgoing variable we are going to select as the least positive value. If there are two least positive value, if there is a tie between two rows, that is, if they have identical least positive value, if they have the same positive value, equal positive values, then there is said to be a degeneracy in the LPP. Okay, if in the ratio column, if you found two values are same, then the problem LPP is said to be degeneracy. Okay, now how to remove the degeneracy? This is basically results when there are more than two lines crossing each other. So that makes a vertex in the solution's place. So if there are more than two lines crossing each other, then that will make a vertex in the solution. So if three lines, see first line, second line and third line. Suppose if these three lines will intersect at this point, the three lines crossing each other form a vertex at this point, then there is more than two lines crossing each other, then makes a vertex at that point. So the degeneracy in LPP may result in the simplex procedure to the cycle indefinitely. So that is, the simplex may move from one iteration to another iteration without any improvement in the solution. Without improving any result or without improving the solution, it will move from one iteration to other iteration. So these are the three lines crossing each other at the point of the vertex. So this is the solution space. Next, suppose now how to solve these degeneracy problems, the step-by-step procedure to solve the degeneracy. So now step-by-step procedure to solve a degeneracy or to break the tie. How to break the tie? So there are few methods which we have to follow to break the tie. The first step is consider two or even more than two, that is three rows which may have the identical least value in the ratio column in any given iteration. So just consider the two or three values in the ratio column which will have the same identical values. Then go to the stage 2. What is the stage 2? At that given iteration, consider the unit matrix formed by the basic variables with themselves. Consider the unit matrix like 1 0 0 1 or 1 0 0 0 1 0 0 0 1. So consider the unit matrix formed by the basic variables with themselves. Usually we will get 2 rows 2 column and 3 rows 3 column identity matrix. Now come to the third step. What is the third step? Find the minimum of the ratio using those identity matrices. So using the identity matrices, find out the minimum value, minimum ratio. Now how to find the minimum ratio? This is very simple concept, elements of the first column of the unit matrix, elements of the first column 1 0 0 1, this is 2 rows 2 column, this is row 1 row 2, this is column 1 and column 2. Now consider the elements of first column, elements of the first column of the unit matrix, first column of the unit matrix divided by corresponding element of the entering column, corresponding elements of the entering column. So here the elements of first column of the unit matrix divided by the corresponding elements of the entering column, entering column. Okay, now only for the tie rows, only for the tie rows, select that row where the algebraic value is the least and select that leaving row. Okay, find out the, for the tied rows, for tie rows, select where the algebraic value is least. Okay, the algebra value is least and select that as the leaving row, outgoing row. So after solving for the tie, find out the least value as usual, find out the least value in the ratio table, then select that row as the leaving row. If there is a tie, once again, if it is not eliminated, if we get the same values more than 2 times again, then again if there is a tie, we have to go for the next step. So what is the next step? Once again if there is a tie, go for the next step. See here. So the first step, what is the first step? First step is consider the 2 or even more than 2 rows which may have the identical least value in the ratio column in any given iteration. Consider the values which will have the same ratio in the ratio column, more than 1, more than 2, if or more than 3. Now go to the second stage, step 2. At the given iteration, consider the unit matrix formed by the basic variables with themselves. Find out the identity matrix formed with the basic variable by themselves. So usually you will get 1001 or 100 010 001 identity matrix. Now go to the step 3. Then find the minimum of the ratio. How to find the minimum of the ratio is important. So here the minimum of the ratio is calculated using the formula elements of first column of the unit matrix, these are the first column, elements of first column of the unit matrix divided by corresponding elements of the entering column. So if this is the entering column, say x1, x2, x3 is the entering column, divide by the corresponding elements of the entering column. Now find whether if again, once again if there is a tie, if we get the same values in the ratio column, more than 2 values as the same values, or if even 3 values as the same values, hence there is a tie. Again the tie is removed using the next step. Only for the tied rows, select the row where the algebraic value is least and select that leaving row. In case if there is a tie, once again we have to go for the next step. In the next step, same procedure we are going to follow. Find the minimum of the ratio. Same. For the next stage, the minimum of the ratio, there is a small change. Elements of the second column. So we are going to consider elements of the second column, column 2. Okay, elements of the second column of the unit matrix divided by corresponding elements of the entering column, entering column. So here the minimum ratio, minimum value is determined using the formula elements of the second column of the unit matrix, elements of the second column of the unit matrix divided by corresponding elements of the entering column. Now similarly, only for the tied rows, select the row where the algebraic value is least and select that as the leaving row, okay, outgoing row. In case if there is again a tie, once again there is a tie, then we have to go for the next step, okay. Now in the next stage, that is step 5. Now find the minimum ratio, same procedure. To find the minimum ratio, first we have considered first column, for the second it is second column. Now for the third column, 100 010 001 in case if it is 3 rows and 3 column. So the elements of the third column of the unit matrix, the elements of the third column of the unit matrix divided by the corresponding elements of the entering column. That's it. The corresponding elements of the entering column will give the minimum ratio. Okay. So only for the tied row, select that row where the algebraic value is least and select that as the leaving row. If there is a tie, once again go for the next step, which involves the fourth column and so on. Okay. Until we are going to eliminate the tie. So this is the step-by-step procedure to solve the degeneracy problem in LPP. Hope you followed this. Okay. Now, let us come to a small example. Let me solve a problem based on this. Now, resolve the degeneracy and solve by simplex method. So, the problem is resolve the degeneracy. Resolving the degeneracy and solve by the simplex method. What is the problem given? First, check whether it is maximum. So, the given problem is of maximization type. So, the max z is equal to 3x1 plus 9x2 subjected to the constraints x1 plus 4x2 is less than or equal to 8, x1 plus 2x2 is less than or equal to 4, where x1 and x2 are greater than or equal to 0. Now, so the given problem, convert this given problem into standard problem, then we will check whether the degeneracy, whether we will get the same values in the ratio or not. If we get the same values in the ratio column, we will go for the resolving degeneracy, and by using simplex method we can find the solution. Now, let us convert the given problem into standard problem. Since what is given, maximum of z is equal to, max z is equal to 3x1 plus 9x2, and taking the coefficient of s1 and s2 as 0 and 0. So, this becomes 3x1 plus 9x2 plus 0 s1 plus 0 s2. Introducing slack and surplus variables. Again, this subjected to the constraint. The constraints can be written as x1 plus 4x2 plus s1 is equal to 8. And similarly, the second equation is x1 plus 2x2 plus s2 is equal to 4, where x1 comma x2, s1, s2 are greater than or equal to 0. Just by introducing the slack and surplus variables, the given objective function and the constraints can be converted into the standard form, as the standard problem is maximum of z is equal to 3x1 plus 9x2 plus 0s1 plus 0s2 subjected to the constraints x1 plus 4x2 plus s1 is equal to 8 and x1 plus 2x2 plus s2 is equal to 4, where x1, x2, s1, s2 are all greater than or equal to 0. Now, just find out the initial vectors first. So, for initial vectors, write down the coefficients here x0, x1, x2, s1 and s2. So, for the first equation, the coefficients of x0 are 8 and x1 is 1, x2 is equal to 4, s1 is 1, s2 is equal to 0. And for the second equation, the coefficient of x0 is 4 and x1 is 1, x2 is 2, s1 is not there 0, s2 is 1. See here, this will form an identity matrix of order 2 rows and 2 columns. So, for constructing the initial simplex table, we are going to consider the initial basic vectors as s1 and s2 with the coefficients 1 and 0, 1, 0, 0, 1 form an identity matrix. So, therefore, we are going to consider this for constructing the initial simplex table. Okay. Now, using these elements, let us come to the initial simplex table. Now, let us construct the initial simplex table by taking the elements. For the initial vectors, we have s1 and s2 as the initial vectors, and the coefficient of s1 and s2 are basically 0. So, we have assigned 0 and 0 for s1 and s2. So, s1 is 0, s2 is equal to 0, and here from the objective function, the coefficients of x1, x2, s1, s2 are, the coefficient of x1 is 3, x2 is 9, s1 and s2 are 0 and 0, 3, 9, 0 and 0. Write down the values of x0. Here the x0 for the constraints are 8 and 4. This is 8 and 4. And the values of x1 as usual. So, we have written here, see 8 and 4, 1, 4, 1, 0, 1, 4, 1, 0. And the second 4, 1, 2, 0, 1, 1, 2, 0, 1. Now, find out the value of delta j. Okay. Now, first step is delta j. How to find out delta j? Just multiply these two. 0 into 8 plus 0 into 4 is equal to 0. 0 into 8 is 0. 0 into 4 is 0 again. 0 into 1 is 0 plus 0. This is 0 you will get. Since we are multiplying each and every element by 0, we will get 0 itself. 0 into 4 is 0 plus 0. Again 0 into 1 is 0 plus 0 is 0. Again 0 we will get. All the values in delta J are 0. Now find out the value of delta J. Delta J is equal to Zj minus Cj. All the values in Zj are 0, 0, 0. Find out the value of delta J minus Cj. So just delta J is equal to Zj minus Cj. Zj minus Cj, 0, this is we don't have. 0 minus 3. 0 minus 3 is minus 3. 0 minus 9 is minus 9. 0 minus 0 is 0. 0 minus 0 is 0. Now identify the least negative value in delta J. In delta J, the least negative is minus 9. Minus 9 is the least negative. Therefore, this is the incoming variable. Incoming variable. So that is incoming column. This is called the incoming column. So this is the incoming column. That means x2 is incoming. x2 is incoming column. Okay. Now find out the ratios. The ratios are given by the ratio is equal to x0 divided by the incoming variable is x2. Okay. Now first one, what is x0? We have 8 divided by 4. 8 by 4 is equal to 2. Again for the second row, x0 is 4, x2 is 2. 4 divided by 2, that is equal to 2. So 4 divided by 2. So what is this equal to? 2 and 2. So we got same values. The ratio for row 1 is 2 and for row 2 is also 2. That means there is a tie. These two values are same. So there is a tie. Now we have to remove this tie. For this we are going to use the procedure just to find the minimum. We have a formula. Using that formula we can find out the minimum value for the row 1 and row 2. Okay. So this is how we are going to check whether we will get a tie or not. Okay. Now here observe carefully. What are the elements of unit matrix? So this will form an unit matrix. This is an unit matrix, and the elements of incoming column are, these are the elements of the incoming column. Now to find the minimum value is determined using the formula. I will go to the step back. Here what is the formula? So minimum value can be determined by element of the first column of the unit matrix divided by corresponding elements of the entering column. Elements of first column of the unit matrix. First column of the unit matrix means here first column of the unit matrix are 1, 0. So divided by the elements of the incoming variables divided by this x2. S1 divided by x2 first. So that is nothing but 1 divided by 4. 1 divided by 4 and 0 divided by 2. These are the values we are going to get. So here 1 divided by 4. 1 by 4 is nothing but 0.25. And 0 divided by 2. 0 divided by 2 is equal to 0. So this is 0.25. Another one is 0. So here the values of the ratios for S1 is 0.25, that is for S1, and for S2 it is 0. So check whether they are equal or not. So they are not equal. So the tie is break here. So the ratio for R1 is 0.25 and R2 it is 0. Identify the least positive value. As usual, identify the least positive value. Here the least positive and go for the outgoing variable. That's it. See here, just how to find out the minimum value. The minimum value is given by x1 divided by x2. That means the elements of the first column of the unit matrix divided by the elements of incoming column. That is nothing but s1 divided by x2. In this case 1 by 4 and 0 by 2. 1 by 4 is 0.25 and 0 by 2 is equal to 0. Hence the values, the ratios are different. So the tie is break here. Hence identify the least positive value. The least positive value is 0. Therefore these are the outgoing variables. So the degeneracy is solved here. Now find out the outgoing variables. So these are the outgoing variables. That is, this is the outgoing. and find out the key element. As usual, the key element is nothing but the key element is this is the key element. So this is the key element. The intersection of these two. The key element is 2. So therefore, key element is equal to 2. Right. Now, let us go to the next iteration. In the iteration table, convert this element 2 as 1 by dividing entire row by 2. R2 dash is equal to R2 by 2 and convert the element above this 2 as 0. Convert this 4 as 0 using the elementary row operation. So, and check, that's it. Okay. Now, let us go to the next table. So, in the iteration number 1, just observe what are the values here. Outgoing variables. So, S2 is outgoing and incoming is S2. S2 is replaced by X2 and the coefficient of X2 is 9. Okay. So, in the next table, S1, S2 is replaced by X2, the coefficient of X2 is 9 and S1 is 0 as it is. Okay. And the values are same, 3, 9, 0 and 0. Now, find out the first, find out R2 dash. R2 dash is equal to R2 dash is equal to R2 divided by 2. Write down the elements of R2. 4, 1, 2, 4, comma 1, comma 2, 4, comma 1, comma 2, 0, 1, 0, comma 1. Okay. Now, we are dividing by 2. Divide each and every element by 2. So, what you will get? 4 by 2 is 2, 1 by 2, 2 by 2 is 1, 0 and 1 by 2. Substitute these values in the table. So, here we will get R2 dash, this is 2, 1 by 2, 1, 0 and 1 by 2. Okay. Now, to find out R1 dash, here R1 dash, convert this element 4 as 0. Now, R1 dash can be written as R1 dash is equal to this R1 minus 4 times R2. That's all, because here we have 4. So, for this just subtract with 4. 4 minus 4 will give 0. That can be written as R1 dash is equal to R1 minus 4 times R2 dash. What is R1? Just take the elements. Elements of R1 are what we have here, 8, 4, 8, comma 1, 4, 8, 1, 4, then 1, 0. 1, 0. Elements of R1. R2, multiply R2 with 4. Multiply this with 4. So, then what you will get? That is 4 2s are 8. Again 4 by 2 is 2. Again 4 1s are 4. Again 4 into 0, 0. 4 by 2 is 2. Subtract this. So, if you subtract, what you will get? 0, minus 1, 0, 1, minus 2. Okay. So, here R1 dash is equal to R1 minus 4 R2. R1 is, what are the elements of R1? 8, 1, 4, 1, 0. And R2, the elements of R2 are these, the new elements, R2 dash, actually it is, make it as R2 dash. So, the elements of R2 dash are 2, 1 by 2, 1, 0 and 1 by 2. Multiply this with 4, 4 2s are 8, 4 by 2 is 2, 4 1s are 4, 4 into 0, 0, 4 by 2 is 2. Subtract, 8 minus 8, 0, 1 minus 2 is minus 1, 4 minus 4 is 0, 1 minus 0 is 1, 0 minus 2 is minus 2. Our intention is to convert this as 0. Now, go to the table. I will substitute here. This is 0, minus 1, then 0, 1 and minus 2. So, these are the values of S1 and X2 column, row 1 and row 2, the elements of row 1 and row 2 in the first iteration table. As usual, find out the value of Zj and delta J, Zj minus Cj, that is it. Now, find out the value of delta J. 0 into 0 is 0, 9 into 2 is 18, 0 plus 9 into 1 by 2 is, this is 9 by 2. Again 1 into 0 is 0, 9 into 1 is 9. Again 0 into 1 is 0, 0 into 9, 0, it is 0. Again 0 into 1 is 0, 9 into 0 is 0. 0 into minus 2 is, that is 0 itself, 9 by 2. Again this is 9 by 2. So, the values are 18, 9 by 2, 9, 0 and 9. Now, find out the value of delta J. Delta J is equal to Zj minus Cj. So, this is 18 as it is, 9 by 2 minus 3, 9 by 2 minus 3, take LCM, 9 minus 2 3s are 6, this is equal to 3 by 2, The first value is 3 by 2. Again 9 minus 9, 9 minus 9 is 0, 0 minus 0 is 0, 9 by 2 minus 0 is 9 by 2. Since all the values in delta j are greater than or equal to 0, that means all the values in delta j are greater than or equal to 0, that means all the values are positive. Hence the optimality is reached. Optimality is reached at this stage. So hence the maximum value is, this is the maximum value, maximum is 18 at x2 is equal to 2, and since there is no x1 term, x1 is 0. So therefore x1 is equal to 0 and x2 is equal to 2 and z maximum is equal to 18. So this is the required answer. This is the method to solve the problem of degeneracy type. So first identify if there is any tie, if there is a degeneracy, and remove that tie by using the formula, and then after removing that tie, go for the next iteration, simplify, identify whether all the values in delta j are positive, greater than or equal to 0, then the optimality is reached. You can find the solution. So therefore the function is maximum at, therefore the value of x1 and x2. So here x1 is equal to 0 and x2 is equal to 2, and z maximum value of z is 18. So if you want, you can verify from the objective function. What is the objective function? Maximum of z is equal to, what is given? Maximum of z is 3x1 plus 9x2, 3x1 plus 9x2. Substitute 3 into, what is x1? x1 is 0 plus 9 into, what is x2? x2 is 2, 0 plus 9 to the 18, this is equal to 18. So z max is equal to 18 at x1 is equal to 0 and x2 is equal to 2. That's all. This is how we are going to solve a linear programming problem of degeneracy type. Hope you followed this. Okay, this is very easiest important problem for 8 marks. Hope you followed. Let us meet with a different problem in the next class. Thank you very much.